Okay, in today's video, I am going to discuss about the vector analysis chapter, which is the first chapter in the syllabus of the electromagnetic theory. In the vector analysis chapter, the first thing that we will discuss, that is the coordinate system. After finishing the coordinate system, I will go to the vector calculus part actually. So this is the coordinate system. See, what is a coordinate system? Let us first discuss about it. What is a coordinate system? For that, let us consider a three-dimensional plane. Let me draw a three-dimensional plane first. This is a three-dimensional plane. Inside this three-dimensional plane, let us consider there is a point P. And also consider, let this is the x coordinate, this is the y coordinate, and this is the z coordinate. Let us consider it. So inside this xyz three-dimensional plane, there is a point P, and can I determine the position of the P with respect to this x, y, and z? Yes, definitely I can. For that, what I have to do? I have to find the value along the coordinate x, y, and z for that particular P. So from here, as this point P is in the three-dimensional plane, that's why the coordinate of the point P that can be given as a x1, y1, and z1. So I can easily determine the position of the point P in the three-dimensional plane x, y, and z, where x, y, z, that is nothing but a coordinate system. So what is the coordinate system actually? Coordinate system is a method which is used to determine the position of a point in three-dimensional plane. As in electromagnetic theory, I will not talk about the plane because the word plane is very much familiar with the engineering mathematics subject. But in case of the electromagnetic theory, the word plane is substituted by the vector space. Basically, here xyz is nothing but the vector space. So I can write what is the coordinate system. I can write the definitions like, just a minute. So what is the definition of coordinate system? It is used to determine the position of any point P in a three-dimensional I will not say plane here. Basically, in electromagnetic theory, the word plane is vector space, three-dimensional vector space. That is the definition of the coordinate system. Okay, and this definition is very much important. You have to remember it. Sorry, three-dimensional vector space. See, that is actually the coordinate system. Now, if I talk about, are there only XYZ a single coordinate system? No. See, from your childhood, you have only seen the XYZ coordinate system, but in reality, or in case of the electromagnetic theory, there are total three kinds of the coordinate system. The number one is Cartesian coordinate system. Number two is cylindrical coordinate system. Cylind and the number three or the last one is spherical coordinate system. Now, the Cartesian coordinate system can also be given as or called, let's say, be named as XYZ coordinate system. Cylindrical coordinate system can also be named as a rho phi z coordinate system, and the spherical coordinate system can also be known as a r theta phi coordinate system. Now, why XYZ, rho phi z, and r theta phi? I will discuss about it in the later on. And what are they? I will discuss in details about that. Don't worry. So, in this video, I will only discuss about the Cartesian coordinate system. So, let me write this heading as a Cartesian coordinate system first. In the next videos, I will discuss about the cylindrical coordinate system and the spherical one. And also, you guys are very much familiar with the Cartesian coordinate system. So, it will be very easy to understand the easier thing first. So, Cartesian coordinate system, which is also known as the XYZ coordinate system. Okay. So, let me bracket it because it is a heading. Okay. So, our current topic is Cartesian coordinate system. But before going to the Cartesian coordinate system, okay, one more thing I want to discuss here before going to the Cartesian coordinate system. That is, just a minute. Before going to the Cartesian coordinate system, I want to discuss one more thing, that is a position vector. What? Position vector. See, what is a position vector? What do you mean by position vector? As I have already told, that is, in case of the electromagnetic theory, this XYZ is what? XYZ is nothing but the vector space, and this is a three-dimensional vector space. In the three-dimensional vector space, in case of the coordinate system, I can also consider there is a point, and in case of the three-dimensional vector space, I can consider a point vector over there. So let us consider a vector, or better to say the point vector, in three-dimensional vector space. Let us say this is the AP. Now, as the vector is in the three-dimensional vector space, that's why it must have the three components along with the three directions. What are those three components? Let us consider. The three components are AU in the direction of U, AV in the direction of V, and AW in the direction of W. Where U, V, and W, these three are called the parameters. These are three are called. So if you can't understand this point, don't worry. I will draw a diagram for you, which will help you to understand this point. Because depending upon the position vector, I will discuss each and every coordinate system actually. So that's why it is very much important to understand the position vector first. So the diagram is the same diagram. There is a three-dimensional plane in case of the coordinate system, which is called the vector space actually. And before that, let me drag it here. So let me drag it here. Okay. So now, this is a three-dimensional vector space. Okay, and let me remove these unnecessary components. Now, inside the three-dimensional vector space, where the parameters are what? U, V, and W. That is, let us say this is the U, and this is the V, and this is the W. Let us say it. Now, there is a, as the U, V, W is a parameters of what? Parameters of three-dimensional vector space. In short, I am writing it VS. So this UVW is not like a normal three-dimensional plane. It is a three-dimensional vector space. And inside the vector space, let us consider a point which is AP. Now, as the point is inside a three-dimensional vector space, that's why AP is not a single point or the normal point. It is a vector. And this vector is nothing but a line vector. What is that? So let me draw it. This is the vector. It is a vector, it must have some magnitude and the direction, and this vector is this vector has the three components along in the direction of u, v, and w respectively. Okay, so that's what I have written over here. There is a positional vector. Now let's come back to the main topic, today's main topic, that is the Cartesian coordinate system. Oh, just a minute. So our main topic is Cartesian coordinate system. Now, in case of the Cartesian coordinate system, understand this point very much clearly. In case of the Cartesian coordinate system, the parameters UVW, see UVW is a general or the generalized three-dimensional vector space. So in case of the Cartesian coordinate system, let us consider this UVW is x, y and z. Sorry, I am not considering it. It is a standardized. So the standardized U, V and W is now x, y and z. Okay. So that is the first point. That's why the Cartesian coordinate system is also called the XYZ coordinate system. Because the parameters in case of the Cartesian coordinate system or in the three-dimensional plane of the Cartesian coordinate system, the parameters are x, y and z respectively. As u, v and w has been given by x, y and z, then what will be the position vector AP inside the Cartesian coordinate system? Very much easy. That is the ax in the direction of x. It is a three-dimensional vector, so that's why it must have the three components. Ay in the direction of y and az in the direction of z. It is a three-dimensional vector. And how this coordinate system looks like, which is very much important. That is the same look, basically. Same look as a UVW or the same normal three-dimensional plane. Okay. Where the parameters are x, y and z. So this is the x, this is the y and this is the z, where x, y, z are orthogonal to each other. Okay. I will talk about the orthogonality later on. So first of all, let us understand this coordinate first, which is very much important. See, now inside this Cartesian coordinate system, now I am considering a slab or a block. See, now I am going into depth analysis. Okay. So whatever I am doing, just listen to this. Ultimately, at the end, you will understand what I am trying to do. Okay. So don't be hurry. Just I am drawing a volume or the block inside the Cartesian coordinate system. Because the block is itself three-dimensional, so that's why I am drawing a block here. So let me draw it. It will take some time. Just be patient. See, this is a I'm considered this block inside the three-dimensional vector space, which is nothing but a volume. Okay, the block is nothing but a volume in the three-dimensional vector space. And see, let this is a point. I think you can't see it. It is a point on that three-dimensional vector space, and this point is nothing but a point vector like AP, like AP. Okay, and it is a point vector, so that it must have the three dimension and the three values in the direction of x, y, and z respectively. So, so let us see what are those three values x, y, and z of this particular point vector. See, this is a point P. Okay, the three values, if I consider the block, the length, width, and the height of the block, this is nothing but the three values of the three-dimensional vector space. Sorry, of the point in the three-dimensional vector space. What is that? See, this is the y value of this point. This is the x value of that particular point, and this is the z value of that particular point. What are they actually? This is the y. Um, I'm sorry. Yeah, what happened? This is the y. This is the x value, and this is the z value of that particular point. You can say, what is the y value? Y value is nothing but the distance of that particular point from x, right? Along in the direction of y. That is this y. Okay. Now what is the z value? Z value is nothing but the distance towards the z direction above the xy plane. That is this z. And what is the x value? X value is nothing but the distance of the point from the yz plane towards the x. So that is the x value over here. Now, I have already told, as this point is nothing but a vector, or this is also called the point vector, so it must have the three directions also. Now let us see what are the three directions. Now, which is very easy. Now three directions, those three directions are nothing but along with the x, y, and z directions. That is, it has the same direction towards the y, which is called the a of y. See, first let me draw the three directions. I will make you understand later on. Yes. See, these are the three directions. You can see that the three directions are the same as of the direction of x, y, and z. Yeah, definitely, because the point is positioned in the xyz three-dimensional vector space. So as it is a vector, it must have the three directions along with the direction of x, y, and z. Now the direction towards x is denoted by ax, basically nothing but the unit vector of x, because you know that unit vector gives you the direction. I think in the engineering mathematics subject you have studied. Now the direction of this point towards the y is known as the ay, and similarly the direction of that point vector P in the direction of Z is known as the AZ. Okay, right? Not only that, AX, AY, and AZ, these three are the unit vector along the X, Y, and Z for that particular point vector P. You can also see this from here. It is AX, AY, and AZ. These three are what? These three are unit vectors, right? Right. These three are what? These three are unit vector, and you know the unit vector gives you what? The very interesting thing in case of the vector in mathematics, that is the direction. In case of the any vector, the unit vector gives the direction only. So that's why ax, ay, and az gives the direction for the particular point AP, point vector AP. Okay, so that's ax, ay, and az I have shown you over here. Now, the interesting thing or interesting fact is, if you look at carefully, that the angle difference between ax or ay or az between the two unit vectors is always 90 degree. That means the angle difference between, let me take another color first. Now the angle difference between this ax, sorry, ay and az, this is the 90 degree, and the angle difference between the az and ax, that is also the 90 degree, and the angle difference between ax and ay, that is also the 90 degree. So that means the angle difference is always the 90 degree. Now as the angle difference is 90 degree, so I can say one important point here, that is ax, ay and az, that means the three unit vectors are what? Orthogonal to each other. The three unit vectors are what? Orthogonal to each other. Okay. Okay. Which is a very important point. When I will discuss the right hand curl rule in later on, this point will come again and again. So whatever though I have written over here, this point. Okay. This point I have written over here. Okay. Now let us see this x, y and z very carefully. Now what is this x, y and z actually? Let us discuss it elaborately. See, let me take color black. Okay, let me discuss it here. So what is x, y and z? What is x? Let us see x. What is that x? X means this x. This x I am talking about. So what is x? For x, you can see whatever x, y and z I will talk about, just you have to look from the direction of x. That means when I will discuss about the x, then what you have to do? Now let us looking from x. As I am talking about x, that's why I am also looking from the x direction over here. Okay. Now if I look from the x direction towards this slab or toward this block, then what I will see? See, when I will look from the x direction, okay, then what I will see? I will only see this YZ plane over here. Okay, right. When I will look from the x direction towards the block, that means towards the block, what I will see? I will see the YZ plane. This plane I will see, this YZ plane of this block, right? Don't worry, I will draw this YZ plane again over here. So what I will see? I will see the YZ plane. Okay, where this is the Y. Basically, these two are two Y actually. This is also Y. The above side is also Y, and this is the Z. And this both side is Z actually. Okay, so looking from the X, I can see this YZ plane of this total slab, and what is the range of this X? Can you see what is the range of this X? Just let me draw it. So this is the X actually, right? Yes or no? This is the X, and this is the positive X direction, and this is, I can also say this is the negative X direction, right? So looking from the X side, I can see the YZ plane, and the range of X is plus X to minus X, right? That means I can also, for the unit vector, using the unit vector, I can also write it as this side is minus X and this side is plus X, right? And this X is perpendicular on the plane. What? Why is it? X is perpendicular on the YZ plane. Okay, so what is X? Can I write what is X actually? That is nothing but, I can also say, that is the perpendicular distance from the YZ plane. See, as this minus X to plus X, this line, this is the infinite line of the infinite distance. So this infinite distant line is perpendicular on the YZ plane. So I can say what is X actually? X is perpendicular distance from what? From YZ plane. From YZ plane, the perpendicular distance is X. And can you say what is the range of X? Range of X is very much simple. X is infinite line from minus infinity to plus infinity, or the minus X to plus X. So range is also the minus infinity to plus infinity. Range is what? Minus infinity to plus infinity. This is the range, because X is a what? Line of the infinite distance. Okay. This is the X actually. In the similar way, I will tell about the what is Y and what is Z actually. So in the similar way, let us discuss about the Y. Okay. Sorry, let me draw this line in the fresh manner. Now I am going to discuss what is Y actually. Okay. So what is Y? See, for X, I am looking from the X direction. Similarly, for Y, I will look from the Y direction. What is Y? A minute. I will look from the y direction. Looking from the y direction means what? Looking from the y direction means I am looking from this direction. I'm looking from this direction. Now, if I look from the y direction, what I can see? If I look from the y direction, what I can see? I can see the xz plane. If you look it very carefully, you will be able to see the xz plane over here, right? Oh, what plane you will be able to see? That is the xz plane. Let me draw this xz plane first. Okay. Yeah, this is the xz plane, where this is the x and this is the z, and the above side is also x and the opposite side is also z. So I'm writing it in a single direction. Okay, so this is the xz plane. Now, what is y? In the xz plane, I'm trying to draw the y, which is the similar like how I have drawn the x. That is, what is this? This is the y, and starting from this y means this is the plus y. Whatever I have shown in the above diagram, above three-dimensional vector space, this is the, according to that, this is the plus y, and this is the minus y. Okay, and not only that, this, and this is the plus y. Plus y means it is in the direction of ay or the plus ay. Similarly, it is the direction of minus ay. Okay, and not only that, this y from the line minus y to plus y, this line is perpendicular above the what? Above the I'm sorry, xz plane, right? This is perpendicular above the xz plane. This is perpendicular above what? The xz plane, right? So now you can write what is y. I can write the y as, it is nothing but the perpendicular distance, similar like x, just like as x. I can write the y is perpendicular distance from the xz plane, right? Y is what? Perpendicular distance xz plane. And what is the range of y? Range of y is same as x, as you can see in the above diagram. That is what? Minus infinity to plus infinity. Okay. Now, just like as y, let us discuss what is z. What is z now? Now for z, what I will look for what? For z, I will look from the direction of Z on the slab. Okay, so looking from Z. Now, if I look from the Z direction over here, now looking from the Z direction means what? I am looking from here. Looking from this direction. Okay. Now, if I look from this direction, what I can see, I will also able to see. I will be able to see only the XY plane, right? XY plane of this slab. So let me draw this XY plane first. From the X direction, I am able to see the XY plane. So let me draw this XY plane first. See, this is the XY plane. You know that, right? This is XY plane means this is the Y and this is the X actually. And this is the Y. Sorry, this is the Z. Means what? According to this picture, this is the plus Z direction and it is the minus Z direction. This is the plus Z direction and this is the minus Z direction. Okay. And if this is the plus Z direction, I can also write then this is the plus AZ and this is the minus AZ. Right. So as this is the plus Z direction and this is the minus Z direction, so above is the plus AZ and the next one is the minus AZ. Right. Okay. Just a minute. Okay. So this is the Z, and not only that, this Z, this line, infinite line, plus Z to minus Z, is perpendicular above the XY plane, right? This is the perpendicular above what? This is the perpendicular above the XY plane, and as it is a perpendicular above the XY plane, just similar like uh, minus X to plus X line, minus Y to plus Y line, minus Z to plus Z line is also the perpendicular above the XY plane. So I can, as it is a perpendicular above the XY plane, so I can write what is the Z actually. Z is perpendicular distance from what plane? XY plane. Perpendicular distance from what? From XY plane. Okay. And what is the range of this Z actually? The range is nothing but same, that is the minus infinity to plus infinity. Okay. So let me draw it here. Okay, just a minute. And just a minute. Okay. That's what X, Y, and Z. I have told you everything. The X, Y, Z. Okay. Now, I think you will be able to understand what is X, Y, Z. Whatever has been written here aside the Cartesian coordinate system. You see, na? Here in the first bracket I have written xyz. This is that xyz definition and the ranges also. Okay. Yeah. Now the very important point I want you to make a note down here, that is nothing but the important point is I have also shown you that these ax, ay and az, these three are the unit vectors along the direction of x, y and z, and the unique property of this unit vector is nothing but ax, ay and az, these three are the perpendicular to each other, right? Ax, ay and az, these three are perpendicular to each other. So I can also write ax perpendicular to ay perpendicular to az. These three are the perpendicular to each other. Now, as these three are the perpendicular to each other, I can say these three are the orthogonal to each other. Now, as these three are orthogonal to each other, then I can say this Cartesian coordinate system, I can say this Cartesian coordinate system is a orthogonal system. The Cartesian coordinate system is what? That is the orthogonal system. Let me write it here. Cartesian Cartesian coordinate system is a orthogonal system. Okay, very important one. Why it is orthogonal system? As the ax, ay, and az are the orthogonal to each other. Very important one, and you have to remember it definitely. So let me box shape. Cartesian coordinate system is what? It is the orthogonal system. Okay. Now I will talk about the very important concept right now. That is the right hand curl rule, RH curl rule. Okay, which is directly related with the orthogonality. Okay. So the next topic inside this Cartesian coordinate system, that is nothing but the RH curl rule. Okay. Just let me write it. RH curl rule for orthogonality. For orthogonality. Sorry, this is the RH curl rule. A very important concept. It will be used everywhere in the communication system. What happened? Okay. I'm sorry, everywhere in the electromagnetic system. See, RH curl rule. That is the nothing but the right hand curl rule. Now, what is the right hand curl rule says? See, right hand curl rule says if this is our right hand, now don't laugh at my drawing. This This is my right hand. If this is my right hand, then just a minute. Let me draw it first. I will make you understand. Don't worry, guys. Now, if this is our right hand, if I cross product the two vectors, see this is the vector 2 and this is the vector 1. If I cross product these two vectors over here, these two vectors cross product means when I will do cross product, I will take those two vectors in my four fingers except the whole finger. Okay, that means as I am doing cross product V1 with V2, see, as I am doing cross product V1 with V2, V1 cross V2. Now the V1 cross V2 is not same as the V2 cross V1, which is very much important. Don't make any misconception about that. As I am doing the V1 cross V2, that means I am doing the cross product V1 from V1 to V2. I will move my four fingers from V1 to V2, from V1 to V2. What happening here? Just a minute. Yeah, V1 to V2. Actually, I am doing cross product between V1 to V2. Now, keeping my right hand and the four fingers from V1 to V2 direction, moving the four fingers from V1 to V2 direction, I will notice where my thumb directed. Now, if I move my four fingers from V1 to V2, my thumb is directed in the upward direction, and this upward directed vector will be denoted as V3, and which is nothing but the resultant vector, that is the V3. Okay, so if you do that, you will be able to see. Now, before that, I want to make you understand one more important point. Now, if you do the V2 cross V1, then you have to move your four fingers from V2 to V1, then keeping the right hand fixed. Keeping the right hand fixed, if you move your four fingers from V2 to V1, you will be able to see your thumb will be directed in the downward direction. Your thumb will be directed in the downward direction. Then your resultant will be the minus V3. Okay, I'm not writing this over here, but what I'm trying to make you understand, see, this is the basic vector cross product rule. So that has been given by the right hand curl rule actually. So whatever I am trying to make you understand over here, that is nothing but if you see the vector v1, v2 and v3 carefully, these these three vectors are orthogonal to each other. These three vectors v1, v2 and v3. These three vectors are what? These three vectors are orthogonal to each other. Okay. And from here, I can conclude about the orthogonality, which this concept is actually used in the electromagnetic theory. Sorry, orthogonality in the electromagnetic theory. Like in EM theory, whatever I have seen, that is also a right hand curl rule in EM theory. I have seen that. What I have seen In case of the unit vector, I have seen, right, ax, ay, and az are orthogonal to each other. That is here, according to the right hand curve rule. See, this is the ax, ay, and sorry. Okay. So EM theory, I have shown you that this was the ax direction, this was the ay direction, and this was the az direction. As you can see that the angle between each of these two unit vector is nothing but the 90 degree over here. Now, as the angle between each of these two vectors, two unit vectors is 90 degree over here. That means it follows the RH curl rule. Similarly, one thing I also make you understand that in the note I have written over here that ax, ay, and az are orthogonal to each other. So I can also write this obeys RH curl rule also. Okay, this obeys the RH curl rule. Okay, now as it obeys the RH curl rule, I can also write it very clearly. That is nothing but it is obeying RH curl rule, right? So I can write ax according to the RH curl rule, ax cross ax cross ay, that will be what? Az. Similarly, ay cross az, just look at this diagram and apply your right hand over here. When I am trying to write a y cross z, that means you have to move your four fingers from a y direction to a z direction. From this to this, you have to move your four fingers. If you move your four fingers from a y to z direction, you will be able to see that your thumb will be in the direction of a x over here. So that's what I am writing here. Okay, and the similar way you can also do for a z cross ax. A z cross ax, that is nothing but the ay. Okay, according to the RH curl rule, I am writing these things over here. Okay. Now, what will happen if I write exactly opposite to this, like ay cross ax? Don't be afraid. If as I am writing ay cross ax, then you have to move your four fingers from ay to x direction, keeping the right hand. Now don't change your hand. Just move your four fingers from ay to a x direction. Just you can move your wrist and align your hand so that your four fingers will curl from ay to x. If you move your four fingers from ay to ax, you will be able to see your thumb will be directed to the downwards. Okay, as the thumb will be directed to the downwards, that will be nothing but the minus az direction, right? In the similar way, what will happen if I write az cross ay? That will be nothing but the minus az direction which will be pointed out. And similarly ax cross az, for that minus ay direction will be pointed out. Okay, which is the basic rule, very simple rule. Just whatever cross product you have been given, just apply the right hand curl rule here, keeping your right hand fixed, and just look at your thumb, in which direction the thumb is pointed out. Okay, right, which is very easy. And one more thing that I can conclude over here, which is definitely the property of the vector, that is where I can write it, that is nothing but ax cross ay is not equal to ay cross ax. Now, most of the students make mistake over here. They think that the this is a normal multiplication, but don't forget that this is the vector multiplication, and in vector ax cross ay is not equal to ay cross ax. It has also been proved over here, because you see here ax cross ay equal to what is it, and ay cross az equal ay cross ax equal to what, minus is it. So these two things are not same. Okay, so this is the another important thing that I wanted to mention over here. So just let me put uh, that is the RH rule, which is very much important. Okay, so that's all about for today. In the next day I will touch the some more parameter in case of the Cartesian coordinate system, that is some differential length, area, volume parameters. I will discuss about it in the next class. So that's all for today, and keep watching my videos. If you have any doubt, you can put your comment in the comment section, and thanks for watching. I will meet you soon.